On the agenda, so there's no homework quiz yet because we didn't finish 5-2. We'll do the 5-2 homework quiz on Friday after we finish that. I'd like to finish 5-2, do questions from the related rates sheet, the most recent one, or even if there's past ones that it's like, hey, now I'm getting to this one, I still have questions on the previous one, that's fine, we can do that too. And then homework questions after that if time permits. I think is the order what I'd like to do that, since we're kind of like in the middle of 5-2, I'd like to close that thought. Yes. Is everybody cool with the plan? That makes sense? So, what we've been working on here is we started the semester talking about antiderivatives, like how to run this differentiation process backwards and reverse. We connected that in some way that this is going to be related to area under the curve, although that hasn't been really solidified as like how exactly those two kind of match up, because we looked at an example of like velocity and like distance traveled being related in some kind of way to the area under a curve. In 5-1 and 5-2, we've been like, okay, how do I calculate the area under a curve? And we've been using this process of, building these Riemann sums, these rectangles, to approximate the area under the curve. And in 5-2, we said, okay, if we take infinitely many of these rectangles, that'll give us exactly the area under the curve. And we've been like running through like, okay, how do I actually evaluate this kind of thing using a limit, get comfortable with these formulas, and that's kind of where we're at right now. In 5-3, we're going to tie a knot, a nice little bow on this, and like connect all this stuff together in a nice, neat package. But we're just not quite there yet. I want to get a little bit comfortable here with the mechanic going on, so you can appreciate when we get to the shortcut how much of a time saver and how nice the shortcut is, just like we did the same thing for differentiation, where it's like you have to really appreciate that like we're skipping through this limit definition to do these shortcuts, but if I don't have a shortcut, it's back to the limit definition I go, same kind of thing here. So we're not going to do, obviously, part A. I don't care about a computer algebra system to do this. Actually, I'm going to write this as. So we know that this expression is called a integral, and this is equal to the limit as n goes to infinity of the sum from 1 to n of f of xi delta x. And if we're using, well, and we know delta x is always b minus a over n. And if we're using right-hand endpoints, xi is a plus I delta x. Everybody's okay? So if we have then I know that A is 1 and B is 2. So delta x should be 2 minus 1 over n, or just 1 over n. And x sub I should be 1 plus I times 1 over n, or 1 plus I over n.
Can you scroll up just a little bit?
Absolutely. How about this?
Perfect.
Meredith?
Is B 2 or
Oh my gosh! It definitely isn't 2, Mr. Kulik. Okay. Now it's fixed. Peyton, was that the same issue?
Yeah.
Thank you guys for keeping me keeping me honest there. You see me making mistakes. Don't stop. Don't let me keep going. Stop me, please. Is everybody good so far? So if I plug this in then, you have the limit as n goes to infinity, the sum from 1 to n of f in our case is e to the x. So I'm going to have e, and then our xi is 1 plus 2I over n. Times delta x. Does everybody feel okay at how I plugged everything in? Okay. We're not equipped to do this any further, because if you remember, to evaluate these limits, we were using these summations as formulas as our tools. And in none of these summation formulas do I have a formula for e to the x. So we're stumped, right? That's why it says in the direction, use a computer algebra program to evaluate this, but this is as far as I would expect you to go. This would be as much as the AP would expect you to go on a problem like this. Okay? And again, on the AP exam, they're not going to have something that takes like 25 minutes to like grind through the algebra on. It's going to be like, here's a limit of a Riemann sum, multiple choice, pick the integral that this is equal to, or here's an integral, pick the limit of Riemann sum that it's equal to. That's the kind of question they're going to ask. It's just, can you convert back and forth between these two forms? Everybody's okay? It says evaluate the following integrals by interpreting each in terms of areas. So we've seen that when I want to do like that limit of Riemann sums and I want to like use the summation formula, it's like an incredible hassle, right? There's certain situations though where like geometry becomes our friend. Because what is this integral really the same thing as? We're still talking about just the area under a curve, right? So if that area is a geometric shape, I can just do geometry to calculate the area and avoid having to deal with any of these nasty summation formulas or any of that nonsense. Everybody's okay? When you see the square root of 1 minus x squared, what do you see?
1. Wait.
What picture is that in your head?
Illustrated cosine?
So, oh boy, that's a thick boy. All right. If I write this, what do you see in your head?
Circle.
Circle! That's what I'm talking about. Circle, yes. So if I want to write this as a y equals, right? This is also a circle, right? What if I take away the minus of the plus or minus? What is it now? Half a circle, right? Everybody's okay?
That makes sense, yeah.
You agree?
I agree.
Because you're getting the part above the x-axis with the plus and the part below the x-axis with the minus, right? Everybody's okay?
Yeah.
Okay. When you look at this, what do we see?
Half a circle.
Half a circle, right?
Yeah.
Is everybody okay? What's the center of our circle?
Radius?
Okay?
Okay.
So, no, not, I mean, the center is not 1. Nope. 0, who said 0? I thought I heard somebody mumble 0.
Sammy said 0.
0 is correct,
Good job.
because the most general form of a circle is this, right? Where h comma k is the center. What is the h here?
X squared.
What is the h? Right? Isn't it 0? If it's just x by itself, write that, right? If there's not minus something inside a parenthesis next to it. Okay. So the center is going to be at the origin, right? So if we think about the graph here, what's the radius going to be? 1. Everybody's okay? Bless you.
Excuse me.
You're excused. So we're looking at this, right? That's essentially our graph. And what part of the graph what part of the area are we looking for? 0 to 1. Ugh, stop. So we're looking for this piece. Everybody agree? What's the area of that?
1/4 of the area of the circle.
And what's the area of the circle formula? Pi r squared. And what's the radius in this case? 1.
Why is only half of the half circle?
Because the integral was going from 0 to 1.
Good, so
That?
it's not negative.
Correct. If it went from -1 to 1, it would be the whole half circle. This was a quarter.
Yeah.
But when I see this part, square root of like constant minus x squared, it's half a circle. That's what I see. Okay? Because in general, if I can, even if I knew how to do this integral by hand, this sucks to do by hand. Like, it's hard. This is a hard one to do by hand. If you see the geometry here, that's what they want you to see. They want you to recognize that as like, oh, that's the graph that looks like a half a circle. I just am going to do this using geometry rather than calculus. Everybody's okay? X minus 1. When you look at that, what do you see? Straight line, right? What's the graph going to look like then?
It's gonna go like the liners up to 7.
Yep.
so.
Yep. So it's gonna look like that, right? Something like that? Everybody agree? Or this is like went 1 over and 1 up, right? Slope of 1. Okay? If I'm going from 0 to 3, and I want like the area under the curve, I want that, right?
Or do we just subtract like the negative from
100%. What shapes am I made here?
the
Triangles. Let's call this first one T1 and let's call this one T2 for the Terminator fans out there. That joke would have really hit like 25 years ago. How do I find the area of the, so, and then our total area then is going to be T2 minus T1, right? Why am I subtracting? Because this area is below the x-axis, right? It's a negative area. Everybody's good? Okay, area formula for a triangle. 1/2 base times height. So in triangle 2, how long is the base?
3.
2, right? From 1 to 3 is 2. And the height is also 2, right? Because this is 3 comma 3 minus 1. Everybody agree? For triangle 1, what's the height? Or what's the base?
4.
1. What's the height?
1.
Well, we're going to say 1 because we've already put the negative sign here, right? If you wrote this as plus, then you could put the negative sign there and that would be fine. But only do it one way, right? You don't want to do, you can't do it both. Everybody's okay? Makes more sense if I'm doing area formulas to put the subtraction symbol and then use all positive numbers in the areas, but you don't have to. You could do what Alice, with plus and then a negative for the height. That's fine.
How did we know to do that? Huh? To the height?
Because this area is below the x-axis. So it's like a negative area.
Yeah.
I'm sorry, what?
For the height of the T2?
How did I know that was 3 minus 1?
Yeah.
Because the function is y equals x minus 1. Is that okay?
Yeah.
Okay. And then you just grind that out and that's easy, right? Now, this integral to do by hand, piece of cake. Like it's as easy as they come. But if all you're given is the graph, if you're given like a general f of x in the picture, geometry is your friend. That's what you're doing.
So should we always start out by just drawing the picture?
Should you always start out? I would say
Like, would that help?
it could. I don't know that it's always,
Okay.
but we're going to talk about like different ways that you can calculate these integrals. And using geometry is going to be one of the methods. There will be AP questions where they expect you to do geometry to find the area under the curve to solve your integral.
Okay.
And there'll be AP questions where it's the only way that you could solve the integral.
Okay.
And there may be AP questions where you could have a variety of methods you could use, and it's one of the ones that you could use. But there will be ones where it's like, we've given you nothing but the picture, and all you have to go on is the picture, and now you're definitely having to calculate the integral by doing geometry to find the area under the curve. Okay? Does that feel okay? And again, like, once you recognize what you're looking at, that's easy to do, right? You're just talking about like, 9th or 10th grade geometry skill that is plugging into formulas, and the formulas are not like crazy formula. It's not like it's the area of a, like a regular polygon here, or it's like, who the heck remembers that formula? It's like rectangles and triangles and circles and stuff that you should remember the area formulas for because they're pretty common. Does this feel okay? Okay. And that should feel a heck of a lot easier than like doing your limit of your sum of Riemann, like that's a nightmare in comparison to this. This was fairly easy once you recognize what it was you were looking at. It's like, oh, circle, triangle, I can handle it. All right. So midpoint rule, this is the same. Integral can be approximated by a Riemann sum where we're using the x value as the midpoint. So the only thing that changes is that our calculation for xi is now a midpoint calculation rather than a right endpoint calculation. So I'm going to start the same way. So if I look at this, my a is 1, my b is 2, and my f of x is like 1 over x, right? So I'm going to calculate my delta x, which is b minus 1 over 5. Why 5? Told me n equals 5. So what I'm doing is an approximation, right? Notice the squiggly there instead of a hard equal sign. What else is missing if it was a hard equal sign? What would have to be here? A limit in front of this, right? It's an approximation if there's no limit. Okay? So I have 1/5 there. Yes? Okay? So notice that we've written xi bar in terms of the xi, the right endpoint. So I need like, so I is going to vary from 1 to n. Okay with that. And we know that xi was this. So xi bar, we're told, is 1/2. Well, let's say right, just do the first one. It's going to be x1 minus 1 plus x1. Is everybody okay there? How I filled things in. To calculate x of 0, jeepers creepers, that's too big. To calculate x of 0, I'm using this formula. So I have a, which is 1, plus I, which is 0, times delta x and to calculate x1, I'm going to have a plus I times delta x. Is everybody okay with what I've written? So now to do this, I have 1 plus 0 plus 1 plus 1/5. So that's 11/5. Everybody agree? If I divide that by, or multiply that by 1/2, it's 11/10. That's my first midpoint. Is everybody okay there? Lucia?
Are you gonna do that for 2, 3, 4, and 5?
Yes.
Okay.
That's exactly what I'm going to do. So I'm going to have x1 plus x2. Here's the nice part. Guess what we already have computed? x1. We did that already, right? That's just this stuff here.
To get the x1, you did x2 minus 1, right? Like in the beginning?
So to get x1, I did a plus 1 times delta x.
Yeah, but didn't you got that from the original equation, right? Like in the beginning when it said to be that x n minus 1 plus x, whatever the number is?
You're talking about this?
Yeah. That's from where?
That's the definition of the midpoint rule.
Is that I minus one? I can't.
Yes. X sub I minus 1. That's why I wrote 1 minus 1 here, for this is I equals 1.
For. Oh.
So this is I equals 2. So 2 minus 1, that's 1, 2. And then I'll have x2 is 1 plus I, which is 2 now. Right? Everybody's okay? So I have 6/5 plus 7/5 is 13/5 times a half is 13/10. And who sees the pattern that's happening here? Just going up by 2/10, right? So I'm going to have 15/10 and then 14/10.
Why is it 15?
It isn't, because I was trying to write x4 and say the thing at the same time, and it is, blech. My brain messages got crossed. 17/10 and then 19/10. Great! So far, so good?
Why is this one? I don't know what's 19.
Okay. So this integral is approximately f of x bar 1 so that's going to be 1 over 11/10 times delta x. Well, actually, let's do it this way. We have delta x, which is 1/5, times 1 over 11/10 plus 1 over 13/10 plus 1 over 15/10 plus 1 over 17/10 plus 1 over 19/10. Everybody's okay? And now we just add some fractions and we're done, right?
Where did you get the 1 over? Like, why is it 1 over everything?
The f in our case is 1 over x.
Okay.
So we're taking those x values and plugging them in into 1 over x. Does that feel okay?
Thank you.
Hey,
Wait, so there's not a limit sign for this?
correct, because if you look at the formula, we're approximating.
Okay.
So if you're approximating, there's no limit, you're just gonna take some number of rectangles, n rectangles, in this case 5 rectangles, and approximate the area with it. If I want exactly the area, then you take the limit as n goes to infinity, we need infinitely many rectangles to get exactly the value. It's good? So if it's an approximation, if it says estimate, or approximate, or about, you're just doing a Riemann sum, right? Finitely many rectangles. Okay. Properties of integrals. These guys go on the memorization list. Okay? The first rule is if I switch the bounds of integration, I pick up a negative sign. So if I'm integrating from A to B, I'm sorry, from B to A, and I switch it to A to B, picks up a negative sign. That's what the effect is. Everybody's okay? If I integrate from A to A, the area under that curve is 0 because the area under a single point is 0, right? These points have no width. So that one we've already kind of talked about, but we're writing it formally here. Everybody feel good? Okay. The integral of a constant. What's the graph of a constant look like? Straight horizontal line, right? What's the area under a straight horizontal line? A rectangle, right? So if I'm looking at the area under C from A to B, it's just going to be the area of that rectangle, right? So base times height.
That's only if there's.
Only if that's a constant, right? If it's a straight horizontal line, the area under the curve is, well, it makes a rectangle. The base is A to B, so B minus A, and the height is C, so just base times height, right? Basically, all you're talking about is a rectangle. Does this come up very often? Not really. Well, it also picks up with our antiderivative rules, like to where it's kind of irrelevant. This guy though, super helpful. What is this guy saying? Well, you can, I would say the other way, but you can distribute our integral symbol across addition or subtraction, 100%. Where else can you do that? Derivatives distribute across addition and subtraction also, right? Because you know what else can distribute across addition and subtraction? Limits. Because really, what is the definition of these things? Both derivatives and integrals, they are limits. So the limit property pushes through into each of those. What's going on here with this property?
I like that one.
Pull out a card.
You can pull a constant out up front. Yep. Where else can we pull a constant out front?
Limits.
Derivatives and limits. We can do for both of them because it works for limits and they're both really just limits. And this one is just saying the same as 2, right? It's just with subtraction instead of addition. Again, these are important properties. You need to know these. They should all be very obvious because they're the exact same properties for derivatives that we already feel comfortable with. Basically, all the stuff you can do with a derivative, you can do with an integral. It's basically what it's boiling down to. Does everybody feel okay there?
Yeah.
Absolutely. All right. It says to use our properties of integrals to evaluate this. Everybody's okay? Let's do that. Okay, first property I might employ.
Distribute across the class.
I love that. Yep, distribute across the addition. I want to point out to you that when we do that distributing, the dx distributes with it. Shh, don't forget the dx when you do your distribute. That comes along with the integral symbol. Think about it as like the period at the end, or the close of a parenthesis, or the period at the end of a sentence. Whenever you start with an integral, you're going to end with a d, whatever the variable is you're integrating. Everybody so far so good? Okay, next property we could use.
Pull a constant out front.
For which one?
3x.
Okay, 3x squared. Because this has a constant too, I just wanted to make sure I knew what you're asking. I don't think there's any thing to be gained by pulling the constant out of that one. Okay, that looks good. So far, so good. What next?
Can we divide? Can we factor out dx?
Well, dx isn't something that's multiplied. It's like the close of a parenthesis. So this is like start, close. You can do something with this, would be what I would look at.
Yeah, it's a.
Yeah, we can do this, right? So I'm going to have 4 times 1 minus 0. And look, we knocked out one integral right away, just using properties.
So we can do that, geometric.
I don't think so, because it's not a circle or a triangle or anything, right? So if you think about what it looks like, you have that, where you're like looking for this area, right? I would say though, I think, if memory serves, let's look back here for a moment. I think we did this, maybe it was in 5.1. Let's go back to 5.1. I think they gave this to us on purpose here. All right, let me go back here and look real quick. So remember this example problem that we did way back here in 5.1? The area under the curve x squared from 0 to 1? That's why they gave us this particular problem, because we can go back and steal our answer from here. I don't think, though, in my excitement, I don't think we ever actually computed anything because I didn't care what the actual value was. Perfect. We'll do it with limits then. I know. It's okay. All right, where did you go? There you are. So far, so good. Meredith.
How did you move the 3 from the second integral to like be added to the first? After the second equals sign?
Right, so we used this property here that allows us to pull a constant out front of the integral.
Oh,
So I still have 4 plus 3 times that limit, right? I'm not going to add 4 and 3 together. Oh, no, no, they're not like terms. Because the 3 has all this other stuff stuck to it.
yeah,
Is that okay?
yeah.
Perfect. All right. So a little bit of cleanup here, but this isn't going to get too bad. So I noticed that the only thing that depends on I is the I here, right? So I can take a 1 over n and then a 1 over n squared and pull that in front of the notation so that it's like an n cubed. So I have that.
Just plug in one for I.
Well, I have to add them up to infinity though. So, yes.
The I over n squared is basically I squared plus 1 over n squared.
Well, it's like I squared over n squared, right?
Yeah.
So then I have times 1 over n gives me I squared over n cubed, and I pulled the 1 over n cubed to the front.
Okay.
Is that okay? Yeah?
Yeah.
Okay. And now this is one of the ones that I have a formula for. So if I scroll back up here to those summation formulas, I can replace this with n times n plus 1 times 2n plus 1 over 6.
We do the summation formulas on the test.
You won't have to do this on a test.
All right.
This kind of thing is just too much time. I have stuff that I'm way more interested in you being able to do that's way less time consuming.
So will there be many of these on the AP exam?
None.
Oh. Okay.
When you get the shortcut thing?
We're gonna start building it out next lesson.
Okay.
Okay, thank God.
Yeah.
Yeah.
Okay. So if I'm looking here, what type of limit am I now left to calculate? Rational function, 100%, yes. Since my limit is going to infinity, the only thing I care about in the rational function is I want to look at the degree of the numerator denominator. What's the degree of the numerator?
Cubed.
N cubed. Denominator.
And cubed.
What do I, and we do the coefficients, very good. What's the leading coefficient in the numerator?
I can't see 2.
It's 2, and in the denominator? 6. So I'm left with then?
1/3.
Perfect. So 4 plus 3 times 1/3? 5. That's our answer.
That should be.
It's such a simple.
Such a simple answer.
Well, the bounds help, going from 0 to 1. We'll see in a minute, like, how to, well, next section, it'll be like, oh, that's all I have to do? Yeah, buddy. It's gonna be a great day. Great day. But it's Friday.
Friday?
Friday.
Alright, I'm really having a good day on Friday.
Meredith's gonna miss it. I'm sorry, Meredith.
Are you not gonna be here? Where are you going? Australia? Where are you going?
Model UN. All right.
That's boring.
Property 5. This is one you need to know, needs to be memorized. Okay? Let's look at what property 5 is saying.
What's the word?
Yeah.
Yeah, it's like a transitive property. Yeah, that's right. So like, if I have like A, C, and B, if I look at the area from A to C, and then the area from C to B, that should be the same as the area from A to B, right? That's all this is saying. Right? So you can hook the two integrals together and just turn it into one. Does everybody feel okay with that property?
Yeah, that's
and feels very common sensey. When you draw the picture, it's like, well, of course that has to be how that works, right? I mean, if you take this area plus this area, it has to give you the whole area, right? All right. Classic AP question. We don't tell you what f of x is. The way we're going to do this kind of a question is with our properties. Okay, so the properties we've looked at. We want to end with the limit from, or I'm sorry, the integral from 8 to 10 of f of x, right? So what I'm going to do is I'm going to find the integral that has the 8 as one of its bounds. And I need to get the 8 in that lower position. How do I switch the bounds on my integral?
Negative.
Make it negative. Okay? Everybody feel good there? Then I'm going to find the integral with a 10 in it. Right here. And I need to make sure that's in the 10 position, or in the top position, which it is. So that can just come down. Oops. And then I notice that, hey, those are the same. So what are they going to do? If I add them together, that then will give me this, right?
Why would it not be negative? Like, where does that negative sign go?
It's plus and negative.
Okay.
Is that okay? So what is the red integral equal to? And what is the black integral equal to? Negative 12. My answer should be then? Done.
So if it was plus a positive, it would still just be,
Be 27 then.
Could you just subtract?
but like for the long thing that you just wrote, it would still be the same. Like the symbols wouldn't switch. For the 10 over 8 f of x d of x.
If this was given to me as 0 over 8,
Yeah,
then this would just be plus.
okay.
I had to switch the bounds though to make this thing line up the way I needed it to.
So if it was given 0 over 8, you just add them together, there wouldn't be like a 2 in front of it or anything, it would stay the same.
Correct.
It just affects the numbers we're putting in.
Couldn't you just subtract them without switching the bounds? Or would that not always work?
Sure. I don't think that'll always work. Depends on kind of the scenario. Sometimes you're given like 3 things that you have to piece together. You know, or you're given like, you have like, instead of missing this one, you're like missing one of these ones. And you have to do like some subtracting algebra to do it. And it just kind of depends on how the problem is set up. But this is a classic presentation. I'd be shocked if you didn't see a multiple choice question on the AP exam that's basically this kind of question. It just checks to see if you understand the properties of integrals to where you can manipulate them to find the missing value. Right? We've cleared out the f of x. Your calculator is essentially useless to you. Like you can't graph it or compute an integral at all with your calculator, which you can do, and I'll show you how to do that at some point, but not for a little while. And then our last set here are the comparison properties. So what this says is that if my function is always greater than or equal to 0, which means it's always above the x-axis or on the x-axis, then the area under its curve has to be non-negative also, right? Which should make sense. Everybody agree? If f of x is greater than or equal to g of x, which means that f is always above g, if we compute the area under F and the area under G, which one should be bigger? F, because it's taller than G, right? That's what we're saying here. And then if we have some function f bounded between some lower limit, some straight horizontal line, and some upper limit, another straight horizontal line, then the area under the curve has to be smaller than the rectangle, the area of the rectangle using the smaller line as the height, and the area of the rectangle using the bigger line as the height. Is everybody okay with that idea? So it says use property 8 to estimate the integral from 0 to 1 of e to the negative x squared dx. So my goal straight away is to figure out in value for little m and big M. What's going to be the best way to kind of try to figure out a value for these? It should be relatively obvious. There's like a tool that you would use.
Differentiate.
We don't want to differentiate. Look at the graph. Just look at the graph. Yeah, that's all I want to do. Right? Let's grab the picture. And if I look at the picture, that should tell me everything I need. So e to the negative x squared. And I just need to go from 0 to 1 is all I care about. And just make that negative 10 to 10. Let's hit graph. What looks like a good upper bound? 1, right? Or 2, fine, 2's fine. 1's a little tighter because it says or equal to, right? So that should be fine. Lower bound?
0.
0, sounds good to me. Anybody object? That'll do. So we know that 0 times 1 minus 0 is less than or equal to this integral, which is less than or equal to 1 times 1 minus 0. So it's somewhere between 0 and 1. Sound good? Fairly easy, right? Just use the picture. Sound good? Okay. That wraps section 5.2. I know.
Are you doing today?
Well, grab your related rates, number 3. I assume you guys are going to want to ask questions about that. Oh, yeah, everybody rushed out of here before I had a chance to do that. I gave them to a few people as they left and asked them to like tell their friends to come back. I don't know if they did. Take one and pass if you didn't get one.
What's the temperature outside?
So you just want to put this on hold then until Friday?
Yeah.
Okay, that's fine. Again, we're gonna do, I've now written the related rates assessment I'm gonna give you guys. It's just a 30-point, it'll go in as a test grade, but as a usual test is 100. This is out of 30. So it's like a third, less than a third of a regular test. The format is gonna be, you have 5 multiple choice questions that are kind of like problems from like set 1 and 2. And then you have 3 like regular questions, we'll call them free response. You can pick 2 to do, so I give you 3, you can pick 2. Those are 10-point each. That's the whole thing.
This is next week?
Probably next week,
Okay.
yeah.
Right, so the multiple choice is 10 points.
10 points total for multiple choice, 2 for a problem. And then the free response are 10 each.
And there'd be a similar difficulty to these.
So like the true response ones would be like sets 3 and 4 questions. The multiple choice would be like sets 1 and 2. I haven't given you the 4th set yet, because ideally I would have given that to you today, but
Will you take them from these, or are you gonna make them?
they'll be similar in format. They won't be like the exact same, but they'll be
Can you just give us all?
close. What's up?
Can't you just give us all sets right now?
You want set 4 also? Yeah, for sure. I got it right here.
I agree with him.
I'm happy to give
I
them.
mean, if you could give it to us next class.
Adrian, you're always.
Doesn't have to be due next class.
Sure.
Just have it.
Works for me.
Wait, so is set 4 gonna be on the assessment then or no?
So the assessment, again, the multiple choice are like from set 1 and 2.
Yeah.
The free response are like from sets 3 and 4.
Oh, okay, I'll.
So again, you know, the stuff that's a little bit more complex, I feel like I wanna see, give you the opportunity to give partial credit for like, did you effectively draw and label a picture? Did you identify like, what's a variable with respect to time and what's not? Did you able to do your elimination? How, you know, did you differentiate correctly? Did you apply a product rule, or, you know, like, where I can assess those things in a way that like multiple choice doesn't allow me to? So like for the simple ones where it's just like, there's not much to do, you just gotta kinda like, here's the equation, you differentiate it, you plug the right things in, and should be able to get the answer,
Yeah.
kind of thing.
Are there certain like equations we should memorize, or are you gonna do most of them too?
I will, here's the deal with the, so Peyton asked about equations. Here's what I would tell you guys, don't worry about volume, do worry about area. Okay, which I suspect is something that like, you probably have all your basic area formulas memorized already. Like circle, triangle, square, rectangle. If you have those, you should be good for areas. Square,
Circle,
pi r squared,
or square, not triangle.
1/2 base times height. Yep. Volume I'll give you. Okay,
Isn't volume different for like what shape it is?
correct. Yeah, any volumes, any shape's volume I would give you. So I have a separate sheet with volume formulas on it that you just can pull the right one from, that you need for the problem.
Pi r squared.
She wanted me to do that.
They would probably give you the volume formula in the problem. If it's, in particular, if it's like a free response, where it's like if you can't do this, if you don't know this, there's like no points to get. 'Cause you have to have it to be able to do anything.
Yeah.
They probably give it to you. It seems that way in the times I've reviewed their free response stuff from previous exams.
Do you grade AP tests? They
No.
give you everything?
I've graded 8 parts of AP tests that my students have taken using the AP grading criteria,
Yeah.
but I haven't like been an AP grader.
I should have taken that. No, I would have.
Okay, so not ready to talk about set 3 today, that's fine. Homework questions from 5-1 or 4-9 that we want to circle back to? Does anybody have anything there?
The only thing I was gonna ask is for, we're doing the, anti-derivatives for like problems like for like something like 15, is there like, do you have to always like simplify first, or is there any way to, just do?
The easiest way is gonna be a small It's massively the easiest way,
Yeah.
because there is no good way to go backwards from emotions.
And I do care if it gets like, what happens if there's, if we,
You don't simplify fully?
yeah.
Okay, good.
I have a question on the,
Yeah, 4.9, let's do it. Do you wanna do it like enough for everybody can see it? You mind? What you got?
can we do 55?
Okay, so I need that page then. One moment while I pull that.
I didn't rush.
Absolutely.
Yeah, you.
You said 55, right?
Yeah.
I think this is nothing.
No.
The graph of f is shown in the figure. Sketch the graph of f if f is continuous and f of 0 is equal to -1. Alice, is it okay if I just kind of draw it on the same paper? Okay. Now I want a little bit of this here. So this is my derivative, correct?
Yeah.
So from 0 to 1, what is the slope of my function?
0.
Positive.
I mean, yes, it's positive, but it's 2, right? And then abruptly at 1, the slope changes to 1. And then at 2, the slope will change to -1, right? So from 0 to 1, the slope should be 2, so I'm going to go 1 over and then 2 up. Everybody's okay? And then from 0 or from 1 to 2, the slope is 1, so I'm going to go 1 over and 1 up. And then from 2 to 3, the slope is -1, so I'm going to go 1 over and 1 down. And I think that'll do it.
Okay, that actually makes sense.
I guess I could look in the back of the book, but I think it's just as simple as that.
How do you
No,
know
that
to
makes
start
sense.
at -1?
Because it tells me in the problem.
Oh.
Yes, that's a fair question. If you missed that, let's see what the
Big snowflakes.
textbook says here.
Thanks.
55.
Is it just like when it makes a graph of a normal off the derivative, it's like opposite?
Yes, that's all they did in 55.
So like when it's constant, it's increasing.
Sure. What's up?
Ask me a question?
Adrian, what's going on?
I was just trying to figure out like when it's like constant, the graph is going up, and then
So,
why does it change to
The
going down?
beginning.
so this says slope is 2, right? This says slope is 1.
Yeah.
This says slope is -1.
So when it's below the x-axis, it's negative.
Because we're looking at the y values, right?
Yeah.
Because the derivative gives us the value for the slope of f, right?
Yeah.
Is that,
So is it like what Lucia said, when it's below the x-axis, the graph decreases?
yes, correct,
That's how it's
yes.
Starting related rates, set 3.
Uh-huh.
When it's talking about water draining from an inverted conical tank, what's the volume equation for that?
1/3 pi r squared h. Uh-huh. Again, volumes in general is just area of base times height. You may have an extra coefficient if it's like got a point to it instead of like just straight up and down. But the base is the circle, so that's the pi r squared.
So you would leave the 1/3 pi alone, and then you do 2r.
Before I start even thinking about implicitly differentiating, I want to look at what are variables with respect to time, what other stuff I'm given, because I wanna see if I have all the like rate variables I need to decide if I need to do an elimination of variable first. Now, we haven't seen that happen yet, because the first two sets have been the easier types of problems. In sets 3 and 4, you're gonna start seeing the need to eliminate a variable, because you're not given all the rate variables you would need to do it directly. So just be careful on that. Adrian,
I was gonna see if we could do 77 if we have extra time.
on the same 4-9?
Yeah.
Sure. Yeah, we got minutes.
What's that?
Is this the physics one? Oh, there's a different physics one. I was thinking of the rock one. There's another rock one that somebody in the other section asked about.
This is like a car or a truck or something.
Yeah, still a physics problem. Okay. Okay. It says a car is traveling at 100 kilometers per hour when a driver sees an accident 80 meters ahead and slams on the brake. What constant deceleration is required to stop the car in time to avoid a pylon? Okay. So we were looking for a value for A of t, right? We know that V of 0 is 100, because that's the instant when we notice, like we hit the brake and things start slowing down, right?
Yeah.
And then I need V of t naught to equal 0, right? And I need that S of 0 is 80. Well, I know it's probably 0, and then S of t naught should equal 80. Now, the way this is currently phrased, my constant of deceleration, let's just make it negative infinity or something, like just comes to an instantaneous dead stop at 100 miles or kilometers per hour, and like smash my face into the steering wheel. But then I'm gonna assume we're just like slowing down, so we stop at the last possible second rather than like instantaneously. But again, like you pick a gigantic number and technically it satisfies the problem as they've asked it. Or, sorry, gigantic negative number, like negative 5,000 or something, that surely will stop the vehicle before you get there. But, is everybody so far so good?
Yeah.
That's his position, right?
Yes, yeah, S is the canonical letter for position in physics. You could use D if you want, or whatever, X. Okay. So, what I'm going to do is, we want to find, okay, we know that like, everybody's okay here?
Yeah.
Okay.
That's kind of where I got stuck. I know.
Yeah, I'm just trying to, there's a, yeah. So this has to be, let's just say that this is K, right? For some constant, or C or whatever, you see. So if I want to then calculate V of t, No, I'm gonna use K. That's gonna be KT plus some C, right? And I know that since V of 0 is 100, so I know that C has to equal 100, right? So I can say V of T is equal to, KT plus 100. And then I know that if I step back to position, I know position of T, S of T is going to equal KT squared over 2 plus 100T plus some other constant.
Oh, no.
Is that okay? And since I know, actually I think I do want to let's make that 80 and that 0. No, I don't think it'll matter. I think it's just going to be fine. Let's do it this way. So if I do that, I know that C has to be 0, right? So I have that S of T is equal to, KT squared over 2 plus 100T. And now I'm going to need these pieces.
Why wouldn't it be plus C1 plus C2?
Well, I mean, you could call this C1 and this C2, that's fine. Right, so C1 is 100 and C2 is 0. So that's fine, you can do that. And then I know V of, well, I can say that 0 is going to equal KT naught plus 100. And I know 80 is going to equal KT naught squared over 2 plus 100 T naught. And what I have now is a system of two equations. So I should be able to solve for T naught and K. The K is really what I want, but the T is like how long it'll take me to slow down. Does that feel okay, Adrian? Do I need to finish the algebra here?
You just, you subtract it, right?
So let's see, I would do, I'd probably do this via substitution, since there's a quadratic here. So I'd say that T naught is equal to negative 100 over K.
Okay.
And then I would substitute that in here. So I'd have 80 equals K times negative 100 over K squared divided by 2 plus 100 times negative 100 over K. And I'd probably just graph that and find the intersection rather than grinding through the algebra, since the algebra looks like it's going to be kind of sucky. Does that feel all right? Maybe it won't be that bad. No, it won't be that bad. Here, we can do it without. So 80 is going to equal 1,000, or 1,000, or no, 10,000 divided by 2, so 5,000. And then over K, and that'll be minus 10,000 over K. And I'll multiply both sides by K. So K is going to be negative 5,000 over 80. I think that'll do it.
Yeah.
So the tricky part, again, the tricky part was kind of getting in to even just the first steps of writing down what are we given in a notation that makes sense for how to solve the problem was a challenge. And then you saw me sit here and have to think about this for a minute. And even when I started doing stuff, I'm like, I wasn't really sure how I was gonna get there. I just had faith that like, okay, I'm just gonna start with my, start with this and just start anti-differentiating out and finding constants and having faith that like, I'm gonna see how to solve this at the end. I'm just like, well, where am I at? I'm in the anti-differentiation section. So I'm probably starting at acceleration and starting to anti-differentiate out. I know about both velocity and position, so I'm probably gonna need both of those two steps along the way. And I saw, like, once I got here that I was gonna have two variables, right, K and T. I was like, okay, well, I know I'm gonna need the position one also now to get a second equation and probably have a system to solve. I'm just crossing my fingers that I was gonna have enough to do that algebraically, but that was the idea, Adrian, is that, again, I would not ask you to do something this complicated, the AP would not ask you to do something this complicated. This is decidedly in like a calculus-based physics kind of question, but I'm guessing that there are more than one person in the room that's planning on engineering school and like this is the kind of crap you'll do in your calculus-based physics class. So like, get used to it, like that'll happen. So it's, again, like, this is, especially late in these homework sets, you see these problems in like the 50s and 60s and 70s can be like quite challenging. And the reason that is just for enrichment for you guys. And the stuff at the end is like way past what I would ask you to be able to do on your own. But like, there's a lot of value in like thinking about this and grinding through it and start thinking about like, what do I need to do to be able to do this? What could I try here? Yes, sir.
When you're finding derivative or actually
You have a specific question?
yeah, like for this one, as ownership on this impose the impact to the negative
You can, it's the natural law.
So it's just
How about I just ask you for that?
This would just be like minus ln.
Yeah, so it's just like you get X and then you can use X.
Minus ln x.
it'd be negative X and then set
Times two, all times
I don't have an answer.
Like 7.